Hey there, Unmaskers! Welcome back to my channel, Unmask It Now. Thanks for tuning in today. On 14 June 2023, AWS released a new feature called EC2 Instance Connect Endpoint to securely connect to your EC2 instances in private subnets without the need for a jump host or a bash-in server. In today's episode, we'll explore how to get started using this endpoint to connect to a Linux or a Windows instance. Before we get to the demo, let's talk about why you would need an EC2 Instance Connect Endpoint. With this new feature released, you can securely connect to your instances in private subnets from the internet. So the instance does not require a public IP, just a private IP. You do not need to attach an internet gateway to your VPC, nor define any routes in your subnet for the internet gateway. There is no need to maintain any jump server or bash-in host that you would typically launch in a public subnet in order to facilitate connectivity to instances in private subnets. As of today, you can use this feature to connect to your Linux instances using both the AWS console and the CLI. However, for Windows instances, this feature is only available via the CLI and not via the console. With the right IAM permissions and security group rules, you can easily access this feature, which we will discuss in detail in the demo later in this video. Let's look into the network architecture now. We have a VPC with two private subnets. We start by creating an EC2 Instance Connect endpoint in any one of the private subnets of your VPC in the AWS account. The same endpoint can then be used to connect over RDP to a Windows instance or over SSH to a Linux instance in any of the private subnets in that VPC. The Instance Connect endpoint and the respective instance needs to be configured with the security group rules as shown in the diagram. The Instance Connect endpoint does not need any inbound rules, which makes this all the more secure. But it does need to allow outbound traffic on RDP or SSH port to the respective instance security group. Simultaneously, the instance security group needs to allow traffic from the RDP or SSH port from the endpoint security group. The end user will need to have the necessary IAM permissions, which I will link in the description below, so that they can interact via the AWS console or CLI to create a secure tunnel to the EC2 Instance Connect endpoint service that resides in the AWS cloud. This will then enable you to RDP or SSH to your instance from your local machine via the CLI or from the AWS console in the case of a Linux instance. Let's switch over to the demo. I'm currently logged into my AWS console in the Sydney region as my administrative user. For this demo, I've already created the VPC and private subnets and the necessary security groups that I need. So let me quickly switch over to the VPC console and show you the resources that I've created. Switching over to the VPC console. I've created the VPC EC2 Instance Connect VPC. Note that I've enabled the DNS hostnames and the DNS resolutions options for this VPC. Let me copy the VPC ID and switch over to the subnets console and list the subnets for this VPC. As you can see, I've created two private subnets in each of the availability zones AP Southeast 2A and 2B. Let's take a look at the routes for this subnet. You can see that the subnet only has the default local route for the VPC, and there are no other routes for the internet gateway or NAT gateway. Let me switch over to the second subnet, and you can see that the routes are exactly the same as the first subnet. Let's now take a look at the security groups that I've created. Switching over to the security groups tab, let me first select the security group that I created for the EC2 Instance Connect endpoint. And let's observe the inbound and the outbound rules. As you can see in the inbound rule, I do not have any rules added. Let's now switch over to the outbound rules. You can see that I have two rules. One for the Linux instance that allows TCP port 22 for the security group of the Linux instance, And I've got a second rule, which is for the Windows instance that allows TCP port 3389 for the security group of the Windows instance. Let me cancel that. Let's now take a look at the Linux instance security group. For the inbound rules, I have allowed TCP port 22 from the security group of the EC2 Instance Endpoint. And as for the outbound rules, I have allowed all traffic. Let's now take a look at the security group for the Windows instance. For the inbound rules, I've allowed TCP port 3389 from the EC2 Instance Connect Endpoint security group. And for the outbound rules, I've allowed all traffic. The security group for the EC2 Instance Connect Endpoint, the Windows instance, and the Linux instance is the same as the tables in the architecture diagram as discussed in the start of this video. Let's now switch over to create the EC2 Instance Connect Endpoint. I'm going to click on the Endpoints tab. Click on Create Endpoint. Call my endpoint EC2 Instance Connect Endpoint. Select the EC2 Instance Connect Endpoint from the service category. For the VPC, I'm going to select my EC2 Instance Connect VPC. I will select the security group that I created previously for the EC2 Instance Connect Endpoint. And I'm going to select the private 1 subnet. So EC2 Instance Connect Endpoint does support client IP preservation. However, for the purpose of this demonstration, we will uncheck this option. Selecting this option means there are additional security groups that you will require, which we will not discuss in this particular video. Let me go ahead and proceed to create the endpoint. Our endpoint is successfully created. However, it is in the pending state. I'm going to give it a couple of minutes for it to be in the available state. I've given it a couple of minutes, and now the EC2 Instance Connect Endpoint is in the available state. Next, I'm going to create a Windows and a Linux instance and then demonstrate how to connect to these two instances using the EC2 Instance Connect Endpoint. However, if you only want to create a Linux instance or only want to create a Windows instance, be specific to only follow along those instructions in the video. Let's now switch over to create our Linux and Windows instances. I'm going to switch over to the Instances tab. Click on Launch Instance. Let me first create my Windows server. I'm going to leave the Windows Server AMI to Windows Server 2022 and the instance type is T2 Micro. Let me select the key pair that I've created previously. For the network settings, I'm going to select the EC2 Instance Connect VPC. I'm going to leave the Windows instance in the private 1 subnet, which is the same as the EC2 Instance Connect Endpoint subnet. For the security group, I'm going to select the Windows security group that I had created previously, and then go ahead to click on Launch Instance. While the Windows instance is launching, I'm going to go ahead and create my Linux instance. I'm going to name it as Linux Server. Select the default Linux AMI. I'm going to leave the instance type as T2 Micro. For the key pair, I'm going to select the EC2 Instance Connect key pair that was created previously. For the network settings, I'm going to select the EC2 Instance Connect VPC. Because we created the Windows instance in private 1 subnet, I'm going to create the Linux instance in private 2 subnet just to show that the Instance Connect endpoint can connect to instances in any of the private subnets of that VPC. So let me select the security group, and this time I'm going to select the Linux security group that was created previously. And I'm going to go ahead and click on Launch Instance. Let us give a couple of minutes for the Linux and the Windows server checks to pass. I have given it a couple of minutes, and now you can see that both my Linux server as well as my Windows server have 2x2 status checks passed. I'm now going to go ahead and create an IAM role, which we will later assume in order to connect to the Windows and the Linux instance using the EC2 Instance Connect Endpoint. Switching over to the IAM console, I'm going to click on Roles and then create a role. I'm going to click on this account, then click on Next. We will add the permissions for this role later. I'm going to name the role as EC2 Instance Connect role. You can give any name that you'd like. I'm going to copy the same name in the description and then go ahead to create the role. Now that the IAM role is created, let's go ahead and create an IAM policy with the limited set of permissions to access the Windows or Linux instance using the EC2 Instance Connect Endpoint. To do so, let me click on Policies and click on Create Policy. I'm going to click on JSON. I have a local copy of the policy. However, you can obtain the policy from my GitHub repo, which I will link in the description below. I have now copied across the policy. This policy has 3 permission statements. The first one, which is listed as additional permissions, is common to both a Linux or a Windows instance. The second permission set only applies if you are connecting to a Linux instance. And the third permission set only applies if you are connecting to a Windows instance. Let's now change some of the placeholder values that is defined in this policy. First, let me change the resource name and obtain the EC2 Instance Connect Endpoint ARN from the VPC console. Let me copy across the ARN. I'm also going to copy it in the Windows section of the policy, since both the Linux and the Windows instance will be using the same EC2 Instance Connect endpoint. Next, for the Linux instance, we're going to leave the default remote port to port 22, which is the default port for SSH. We will then change the private IP for the Linux instance. I'm going to copy the private IP from the EC2 console. For the max tunnel duration, I'm going to define a value of 3600. Switching over to the Windows section of the policy, the default remote port is the RDP port, which is 3389. I'm going to then copy across the private IP address of the Windows instance. And then type in the max tunnel duration, which I'm going to leave it as 3600. Once I've copied across all the values, I'm just going to verify that I have all the necessary permissions in place. And then go ahead and click on Next. I'm going to name the policy as EC2 Instance Connect Policy. Copy the same in the description below. However, you can give any policy name or description of your choice. I'm going to then click on Create Policy. Now that the policy is created, let's go back to the role that we created previously and attach the policy to that role. To do so, click on Add Permissions, Attach Policy, select the EC2 Instance Connect Policy from the drop-down, and then click on Add Permissions. We will first attempt to connect to the Windows instance using the EC2 Instance Connect endpoint from the AWS CLI. Note that for the Windows instance, you can only connect via the CLI, as there is no console option available as of today. Later in the video, we will attempt to connect to a Linux instance using both the AWS console and the CLI. Let's now switch over to the AWS CLI. Let me now list the AWS CLI version. I'm currently on the version 2.12.1, which is the latest AWS CLI version. I would highly recommend that you upgrade your CLI version to the latest version in order to access the API. Let me now list the current user that's connected via the AWS CLI. So I'm going to run the get caller identity API. I'm currently logged in as my administrator user Wiz. I'm now going to use the assume role commands in order to switch over to the EC2 Instance Connect role so that we can get the temporary credentials of that role and use that to connect to the Linux as well as the Windows instance using the EC2 Instance Connect endpoint. So let me copy across the command for the assume role. So this command has the EC2 Instance Connect role ARN as well as just the random name, which is the role session name. You can see that this command has returned the credentials, which contains the access key ID, secret key, and session token, which are the temporary credentials for this particular role. So I'm going to copy across these credentials to my editor and then fill in to get the export commands. So I'm now going to use export commands in order to copy across the access key ID, secret access key, and the session token as environment variables. So let me first export the access key ID. Then going to export the secret key. And finally, I'm going to export the session token for this role. Now that the credentials are exported, I'm going to run the sts get caller identity command again. You can now see that the CLI has switched to the EC2 Instance Connect IAM role. I've also linked these CLI commands in my GitHub repo, so you can access these commands from there. Let's now attempt to connect to our Windows instance. I'm now going to prepare the EC2 Instance Connect Open Tunnel API command for the Windows instance. Let me get the Windows instance ID for my Windows instance. So you can see that this command is the EC2 Instance Connect Open Tunnel command for the instance ID, which is my Windows instance ID, on the remote port, which is the RDP port 3389. I'm using a random ephemeral port that is 65123 with the max tunnel duration as 3600, which was set as a condition in our policy. Let me go ahead and click. You can now see that the command is listening for connections on port 65123. Let's now use the remote desktop client to connect to this Windows instance. So switching over to the remote desktop client, I'm going to click on Add PC and click on localhost with the ephemeral port that we provided here, which is 65124. I'm going to provide the friendly name, which is the Windows server. And for the user account, I'm going to let it prompt for credentials. Let me attempt to connect to it. And you can see that it's now prompting us for credentials. The username is administrator. And let's decrypt the password from the console. So let me select the Windows server, click on Actions. I'm going to select my EC2 key pair. And copy across the password. You can now see that we are connected to our Windows instance using the EC2 Instance Connect endpoint without the requirement of any public IP address or any bash-in servers or jump hosts. Switching back to the AWS CLI, you can see that once the connection for the Windows instance is open, you can see a statement on the CLI that says accepted new TCP connection opening WebSocket tunnel. Let me now exit from the CLI session. I'm going to run the AWS STS get caller identity to verify I'm currently logged in as the EC2 Instance Connect role. We will now attempt to connect to the Linux instance using the AWS CLI through the EC2 Instance Connect endpoint. So switching over to the EC2 Instance console, I'm going to make a note of the Linux private IP. I'm also going to copy across the Linux instance ID for my command. Let me copy across this command to the AWS CLI. So I'm going to run the SSH command. I have my key pair at this location. I've copied across the private IP of the Linux instance. I'm then going to use the proxy command through SSH to connect to the Linux instance using the EC2 Instance Connect Endpoint using the OpenTunnel API. I've now provided the instance ID of the Linux instance with the max tunnel duration as 3600 as described in the conditions in the policy. So let me now hit enter. Let me click on yes. You can now see that I'm connected to the Linux instance using SSH through the EC2 Instance Connect Endpoint. And just like the Windows instance, I did not require any public IP, nor did I require to connect to any bash and host or jump server. You do have the option to connect to the Linux instance using the EC2 Instance Endpoint from the AWS console. So now let's attempt to do that. So switching over to the AWS console, I'm going to switch the role to the EC2 Instance Connect role. So let me click on switch role. Type in switch role. So let me grab the account ID and paste it here. For the role, I'm going to type in the EC2 Instance Connect role. And then click on switch role. You can see that I'm now logged into the AWS console using the EC2 Instance Connect role. It's okay if you are not authorized for some of the APIs here because the EC2 Instance Connect role has very limited permissions specifically to use the EC2 Instance Connect OpenTunnel API. So selecting the Linux server, let's go ahead and click on Connect. Then click on the EC2 Instance Connect and then click on the Connect using EC2 Instance Connect Endpoint. I'm going to leave the username, the max tunnel duration as default, and then select the EC2 Instance Connect endpoint that we have created, and then click on Connect. You can see that you get the error message, failed to connect to your instance with an access denied message. You get this error because you do need additional permissions to use the EC2 Connect endpoint when you're using the AWS console. So let us switch over back to our administrative user and see what additional permissions we do require. So let me go ahead and switch back to our administrative user. So I'm now logged in as my administrator user, and now I'm going to switch over to the IAM console. So in the EC2 Instance Connect policy, when you're attempting to connect via the console, you do require additional permissions for the EC2 Instance Connect send SSH public key. So I'm just going to go ahead and copy across those permissions. So I'm going to click on Edit. And under the additional permissions, I'm going to add the permissions for the EC2 Instance Connect send SSH public key. And then click on Next. And then save the changes. So let's attempt to now connect to the Linux instance now that we have the necessary permissions in place. So I'm going to switch back to the EC2 Instance Connect role. Switch over to the EC2 console. Now that we are connected as the EC2 Instance Connect role, I'm going to select the Linux server. Click on Connect. Click on Connect using an EC2 Instance Connect endpoint. Select the endpoint that we previously created and now click on Connect. You can now see that we are successfully able to connect to the EC2 instance with the additional permissions in place. This concludes the demo for connecting to a Linux or a Windows instance using the EC2 Instance Connect endpoint. Thanks for watching. For more such content, please don't forget to like, share, and subscribe to Unmask It Now. See you next time.